Program to print greatest common divisor of a number using recursion. The greatest common divisor, GCD, of a number is the largest positive integer that divides two or more numbers without leaving a remainder. For example, the factors of 12 are 1, 2, 3, 4, 6, and 12. The factors of 18 are 1, 2, 3, 6, 9, and 18. The common factors of 12 and 18 are 1, 2, 3, and 6. The largest of these common factors is 6, which means that 6 is the GCD of 12 and 18. This line includes the standard input-output library header file stdio.h that contains the definition of input-output functions such as printf and scanf, then defines a function called GCD that takes two integers a and b as arguments and returns their GCD. The function uses the Euclidean algorithm to recursively find the GCD. The base case is when b becomes 0, in which case the function returns a, otherwise, it calculates the remainder of a divided by b and calls itself with b and the remainder as arguments. The main function of the program. It has a return type of int, which means it returns an integer value. Then take two integer variables a and b. And prints the message enter two numbers to find their GCD, on the console. And then use scanf function to read the value entered by user. Prints the message the GCD of a and b is result. And then use return 0 to indicate the program runs successfully and return value is 0. Program runs successfully and after enter 12 and 18 it prints the GCD of 12 and 18 is 6. Question number 2. Program to print roots of quadratic equation. Logic to find the roots of quadratic equation. To find the roots of a quadratic equation in C, we can use the following logic. Take the coefficients of the quadratic equation, a, b, and c, as input from the user. Calculate the discriminant, d, using the formula d equals b squared, for ac. Check the value of the discriminant. Case first. If d greater than 0, the roots are real and different. Use the formula x1 equals b plus sqrt, d, / 2a, and x2 equals b, sqrt, d, / 2a, to calculate the roots. Case second. If d equals 0, the roots are real and equal. Use the formula x1 equals x2 equals b / 2a, to calculate the roots. Case third. If d less than 0, the roots are complex. Use the formula x1 equals b plus isqrt, d, / 2a, and x2 equals b, isqrt, d, / 2a, to calculate the roots, where I is the imaginary unit. The stdio.h library contains functions like printf and scanf for input and output, while math.h contains math functions like sqrt for square roots. The main function of the program, which is the entry point of the program where the execution begins, now declares 6 variables of type float. A, b, and c are the coefficients of the quadratic equation, d is the discriminant, and x1 and x2 are the roots of the equation. Then prints a message on the console asking the user to enter the values of a, b, and c. The scanf function reads the input values from the user and stores them in the variables a, b, and c. Then computes the discriminant of the quadratic equation using the formula d is equal to b squared minus 4ac. This block of code uses conditional statements, if, and else, to check the value of d and compute the roots of the quadratic equation accordingly. If d is positive, the roots are real and distinct, so the program computes the roots using the quadratic formula and prints them on the console. If d is 0, the roots are real and equal, so the program computes the root using a different formula and prints it on the console. If d is negative, the roots are complex, so the program computes the roots using complex arithmetic and prints them on the console. Ends the main function and returns a value of 0 to indicate that the program executed successfully. And then save the file. Program runs successfully, and after entering the coefficient it prints the roots are real and equal. Question number 3. Program to check a number is palindrome or not. Firstly, we have to understand. What is palindrome number? A palindrome number is a number that is equal to its reverse. For example, 12321 is a palindrome number because its reverse is also 12321. Hashtag include stdio.h preprocessor directive that tells the C compiler to include the standard input-output library. The main function is the entry point of the program. Then declares three integer variables n, original number, and rev, with rev initialized to 0. Then displays the message enter the number on the console. Use scanf function to read the number entered by user and store it in n variable. Copy the value of n in original number for later comparison.
And then use while loop that will execute until the n becomes 0.
And then extracts the last digit of n by using the modulus operator and appends it to the rev variable by multiplying it by 10. And then removes the last digit from the n variable by using division by 10. After that checks whether the original number is equal to reverse or not. If original number is equal to its reverse, then print it is a palindrome number. Else print it is not a palindrome number. Return 0 indicates program runs successfully, and enter the number 12 it prints it is not a palindrome number. On entering 112,211 it prints it is a palindrome number. Question number 4. Program to print perfect number in a given range. Firstly, we have to understand. What is perfect number? A perfect number is a positive integer that is equal to the sum of its proper divisors, which are all the positive divisors of the number excluding the number itself. For example, 6 is a perfect number because its positive divisors are 1, 2, and 3, and 6 is equal to 1 plus 2 plus 3. Hashtag include stdio.h includes the standard input-output header file in the program. Function is perfect takes an integer n as input and checks whether it is a perfect number or not. A perfect number is a positive integer that is equal to the sum of its proper divisors, excluding itself. The function initializes a variable sum to 0 and a variable I to 1. Then it uses a for loop to iterate from 1 to n/2, since a number's proper divisors do not include the number itself, and the largest proper divisor of a number n is at most n/2. Inside the loop, it checks if I is a divisor of n, i.e., if n is divisible by I with no remainder. If it is, then it adds I to the variable sum. After the loop, the function checks if sum is equal to n. If it is, then the function returns 1, indicating that n is a perfect number, otherwise it returns 0, indicating that n is not a perfect number. Main function initializes three integer variables a, b, and I. It then prompts the user to enter the range of numbers to check for perfect numbers by printing the message enter the range. The user's input is read using the scanf function, which reads two integers from the standard input and stores them in the variables a and b. The function then prints a message indicating the range of numbers that will be checked for perfect numbers. It uses a for loop to iterate over all the integers from a to b. Inside the loop, it calls the isPerfect function to check if the current number I is a perfect number. If it is, then the function prints the number followed by a comma and a space. Finally, the main function returns 0, indicating successful program completion. And prints the perfect number between 1 and 1000 are 6, 28, and 496. The Fibonacci sequence is a series of numbers in which each number is the sum of the two preceding ones, usually starting with 0 and 1. Therefore, the sequence goes 0, 1, 1, 2, 3, 5, 8, 13, 21, 34, and so on. Hashtag include stdio.h include standard input-output library function. And then we make fib function in which if n is 0 or 1, the function returns n itself. Otherwise, it returns the sum of the two previous Fibonacci numbers, fib-1 plus fib n-2. The main function of the program. It starts by declaring two integer variables, n and I. The next line prints out a message asking the user to input the number of terms in the Fibonacci sequence they want to see. The scanf function reads the user input and stores it in the n variable. The next line prints out a message indicating the number of terms that the Fibonacci sequence will contain. A for loop is then used to iterate over the sequence and print each term to the console using the printf function. The loop starts with I set to 0 and continues as long as I is less than n. During each iteration of the loop, the fib function is called with I as an argument, which returns the ith Fibonacci number. This number is then printed to the console. Finally, the main function returns 0, indicating successful execution of the program. And print 10 terms of Fibonacci sequence are 0, 1, 2, 3, 5, 8, 13, 21, 34.